What's up guys, it's Record. This weekend we are going to look at a way of solving day-to-day life problems that can help us to improve our lives and improve other people's lives. So this Friday in the evening, as I was coming back from work, I found this around my house, and this is a broken pipe from water and sewerage company of Dar es Salaam, I think so, where we get tap water. And by Saturday morning I came back and looked at this part of my wall, and I still saw that the pipe was broken, and I expected these guys to have some way of detecting broken pipes or let's say leaking water. And by Saturday evening still the pipe was still leaking, and it was not fixed. So I thought of a way of finding some solution to such kind of a problem, because if this water is leaking from the company that makes this water and supplies it to the whole city, that means that they are going to be losing a lot of energy, and as they lose a lot of energy, they are going to spoil the environment. To solve this problem, I use this method of solving problems and developing apps. You can check him out on YouTube. I'll put his link on the description. And this is how he solves or develops apps. He begins with, this is the problem, we need a working MVP. In our case, we need a system that can detect whether there is an anomaly in water supply for a city. And my city now is Dar es Salaam. I'm staying in Dar es Salaam for the next 1 month or so. Then for a working MVP, we need to embed a machine learning model in a web app. To embed a machine learning model in a web app, we first need a web app to be developed, and then we need a machine learning model to be trained. And to get a trained machine learning model, we need to collect data. That was so tedious. I moved from one site to another. I tweeted about it. I asked you guys for help for data for this project. In fact, a 1-day project, a 2-day project. I moved from Kaggle to this place, data.government.au, to African geoportal, and it was very hard to get data. In fact, I spent most of the time looking for a proper data set. Then I came to Townsville. Shout out to these guys. They have daily water production, and I assume this is what they supply. And after getting the data, it was time to train the machine learning model. And to train a machine learning model, I came across this post here, because now we are looking for an anomaly. So this post here by Brent, I hope I'm pronouncing your name correctly. He uses LSTM auto-encoder for anomaly detection, and it's a good blog. I'll put the link in the description. You can read about it. And in this case, what we want is to have an auto-encoder that can understand the input. So with the auto-encoder, you have two neural networks working together. One neural network gets the input data, and then the other neural network tries to predict or tries to output the original input. So to train this in this way, what I wanted was that I have a time steps of data. Let's say for the past 4 days, the input has past 4 days data, or past 4 days supply of water, and I wanted an autoencoder to try to regenerate this data. So we have the input, and then it tries to regenerate still the input, and then I compare the output of the autoencoder with the input. So to get an anomaly is if the autoencoder fails to generate the input, like what autoencoder does mostly for images. You give it an image and then it tries to generate an image that looks like that image. So here I am using a time series data. I give it a time series and I want the autoencoder to try to generate a time series that looks like the input time series. But if it fails, then that means that there is an anomaly in the time series, and to get the difference between the input and the output of the autoencoder will help me to determine whether it is an anomaly or not. So I use this guy's code and I try to change it so that it can fit in my situation, and all of this code is in my Bitbucket. The link of my Bitbucket is in the description. So here is much of his code, and I have to change bit of my data and how to scale and what have you. Then from here I also change the model a bit. From here I save the model to disk. After saving this model to disk, we have now the second bit of training the machine learning model check. So here we have an LSTM with an autoencoder. Then it was time to develop the web app. So the framework that I used to develop the web app for this problem was Django. So I created a web app and I called this web app I called it just a project, and then inside the web app I had two applications, and one of the application is autoencoder. So inside here with the autoencoder I have my model saved, and then after creating the app in settings.py, I'm not going to show you or introduce you to these frameworks or maybe introduce you to machine learning models, because there are a lot of resources there. But what I'm doing is showing you how I'm solving problems using the tools that are available to us as data scientists, and one of them is Django. If you want to learn more about Django, I have some good resources from other people, not mine. I put maybe one of them in the description for you guys to look at them. So here in settings.py I have my app. Then from there I had to create a model for it. This is not a machine learning model, this is the database I had to create for it, and this database stores all the information that comes in with the predictions. Then from there in the views is where I have my machine learning my model called. This is my neural network called. There was also a scaler. I had to scale the data to fit between 0 and 1 here in the training, and I had to save that scaler so that I can use it in production. So here I have the scaler, and then from the scaler in the view called home is where the rendering happens. But here in the view called dbWrite is where all the other magic of the model happens, where there should be a prediction, then the difference between what is predicted and the input. If the difference is so big, then that is an anomaly. So here if we go back to my code, we have something called loss distribution, and with the loss distribution what I'm doing here is that I'm trying to compare the input and the output. If the difference between the input and the output is so big, that means that the input and the output, if the difference between the input and the output of the autoencoder is so big, that means that it is an anomaly. And I had to plot the loss distribution so that I can know how it is distributed, and it looks like normal distribution but with the skewed. So this skewed part here, I consider it as an anomaly, and the anomaly that I had to choose here is if the loss that I get is 2 standard deviations away from the mean of the loss, then that loss is considered to be an anomaly. So all this is put inside here, in the views, and I had to scale this and predict and check if find the mean of the loss. Then I check if it is greater than some threshold, and this threshold is just if it is two standard deviations away from the mean of the loss. And if it is 2 standard deviations away from the mean of the loss, that means that it is an anomaly, and returns true, and then this anomaly is registered in the database. So this application here, the urls.py, then this one just to put the URL that will point to the views. Then I render my view in HTML. So let us try to check how it looks like. I hope it is running. Is it running? Yeah, so we have to, so here it is, here is the model. So here is the model running, and this is the output. It refreshes after every 3 seconds. So every 3 seconds I consider as a day. This refreshing should happen after a day. So this is just for the purpose of video, so that you can see numbers changing. So what is happening here is that if there is an anomaly, it will tell you that the supply yesterday was not normal, or the supply yesterday was normal. So let me try to send some data to it. Okay, so every 3 seconds shows represents a day, and you know, after a day is when the data is collected and aggregated, and then it can be sent to the system. If it is normal, then it will register that it is normal. If it is not normal, it will register that it is not normal. So the whole of this code is in my bit bucket. You can go and take a look at it. You can fork, you can clone, and try to improve it. If you have something better, try to give me a shout on my Twitter handle, or you can comment. Try to get my attention, see how you develop this system further that can help a lot of people. It will help our environment, because we are not going to be wasting energy and producing a lot of carbon dioxide outside. And the problem is here, it is being solved without much ado. Peace, and try to save the environment.